good morning to you, or good day, or whatever. So this is just quick overview and maybe quick tutorial on how to manage this kind of the puzzle, because the blueprint which you sent me, to be honest, it was way more complex than it needs to be. So this is kind of very simple. It can even be the modular, but it still can be very simple kind of the code, right? So if you can do the code with five nodes, then in blueprint, then you don't do it in 10 or 20. So keep that in mind every time when you are trying to achieve something. It's something even sometimes even better not to do everything physically correctly or whatever, but just achieve optimal results, especially when these kind of stuffs are in question. So let's dive in. Let me just quickly create actor-based class. So this will work a little bit different than yours. So basically you don't need a parent with actor child and stuff. That's not quite modular. You can always add a listener. You can reference the affected pillars, and so on and so on. So we will do it that way rather than hard coding 3 pillars or something. So we will call it pillar or puzzle. Base PP. So this is now okay. So this is now the base class, and what we need to do is first basically, just as you already have, static mesh component. We don't have to change the name, and as well now depending how you want to manage this, again, if you want to add the interface for interaction or ray tracing, whatever, but we will for these purposes of basically interacting and following the states of the pillar, we will just do the component based, like box collision based. So that would be it. We will now create the function event. Let's create actually event here, not function, because we will need to be in this context. If I think correctly, you are using the timelines, which is completely fine, but it's asynchronous and it's inlined, kind of the inlined function or aspect. So we will have to go through this here. Usually what you would do if you are not working with inline but with some function which works on update, then you would create pillar behavior which will be overridden if you need to make child of this class to behave differently, but we will go over that. So let's first call the custom event behavior if we are about to use again timelines, and then what we need else is basically the timeline. This is our timeline, and we will say rotate, because this is what you actually wanted. Now, if I remember correctly, what you are doing was just quickly add the track. I think that you already know that you actually did it like this. So let's put it here and here, another one here and add 1 and 1. Okay, so that should be it. Next we should make just for the rotator something like this, and we need as well the variable rotate by, which will be float and opened like to be adjusted by instances. Get rotate by, and then we would basically put this one, I think, here, rotate by, and maybe another rotator. This won't work. This won't work because we are doing lerp rotation. So basically what you are doing this, but this is asynchronous absolute values. So I'm not sure that this would actually work if we take this one and then we something like this. So if we get this actor rotation and then as well here let's try it. Let's try it, but I'm not sure that this will actually work. Or maybe like this, or we should create current rotation to remember it. Let's create it doesn't need to be public. So let's say that on begin play we will get rotation and set current rotation to be z of this one. So something like this. Again, will this work? Hardly, but let's see. And it should be on update. Set or set. I think it should be set. You use set actor rotation. Set actor rotation, and now we should basically be okay. But this is weird. I'm not sure this works, so you will have to check that will this work. Does this actually works on your side? Now let me just quickly put static mesh, which I prepared for this. Let me see how does it looks. Okay, this is okay. we want to do is to call on this guy component begin overlap. We will call the event pillar behavior. Just to see would this work. So we want to rotate it. By some degree. I'm not sure to build this work, but usually what we want here on finish as well to put so this should be get current rotation, and we should just copy paste this one here on finish, and again set current rotation on the finish. Current rotation. So let's see what will happen now if we place this guy here and by 90 degrees and then play it from here. So it rotates by 90 degrees. Okay. Okay, yeah. I'm not sure that inside of the timeline the absolute values would work. So maybe it's better to wrap it up into the relative one. So let's do it actually with and this, I think that this is normalized rotation. Problem here is with adding alpha. So let's just try to add actor. So this is the delta rotation. Let's see what will happen. Okay, yeah, that won't do anything, especially not in this system, so we will delete this one. And we will wrap it, we will just wrap it quickly with previous rotation alpha, and it should be always 0 basically. So let's do this, let's deduct then let's multiply this one, multiply this with rotate by angle, and then we can make the rotator. Place the rotator here, and then we need to reset this alpha to be same value as the alpha from rotation timeline. Okay, and as well we need to do actually not this one, but current rotation basically should be. Current rotation added to rotate by current rotation, and it should be set. Go ahead and set to it. And as well, most likely we will need to snap it back, because I'm not sure that this, because this is asynchronous, will this be super correct? But we can check it. It can oscillate a little bit. So now, yeah. Free alpha. Okay, we don't need this one. We don't need that one. No, it works. It rotates by. Let's just try to rotate it by 360 degrees. And it will, yeah, rotate exactly for it. Okay. Okay. We as well, I'm not sure, should we just check are these values correct? Because usually you see there is slight oscillation between, because it's asynchronous, it will always offset a little bit for some degree, so we will have to force it back, in essence, by this value. So let's normalize this, whatever axis is. This axis for the rotator to be between minus, and then we can now do set actor rotation, and we can break this one, split structure screen, and put it like this. So now it should be minimal. Still offsetting for some reason. Unfinished. We shouldn't basically get this issue. Or at least not in the some greater value. Okay, now it works mostly, and I think that this is the reason, because we did not wait for this one to finish in order to second fires. So maybe there is a slight offset with this, but yeah, it will eventually return it to the wrapped. So this is okay. So this is okay. Let's just make it a little bit prettier. This should go like this. It should go here. Likewise, axis should go here. Okay, this should be the pillar function. I think that this would actually work completely fine. Now on begin play, we actually need to do some checkups most likely. Actually, we need to put this. Okay, now it's time for the gameplay possibilities. So you want, for example, let me just put quickly pillar. So usually you want to do some checkups. Will this pillar be self-affected? And as well affects only self. So this is something which you would like to change, right, in the per instance. So what you want to do is on overlap to check does it affect only cell, and put branch here, and then put this one here, and then pillar behavior, and if false, if this is false, then we will have to go and affect self. So we need another branch, basically, branch which will go here approximately, maybe here. Self-affects. So you can basically manage, does it affects only self or self as well, and then you as well, what you want to add is another variable of the affected pillars. So now you can have multiple pillars instead of 3, or maybe 2 if you want. Now I don't want to get in optimization and hard references and stuff like that, but we will just keep it simple. And put a hard reference in it. So after you have done this, basically we need to put this one here. If it affects self. And if it doesn't affect self, we must get these pillars. Sorry, it has to be array. So array, get affected array for each, and then basically call from for each loop you need to call every event, every pillar. So we need actually to do this, because in this both of the cases you want to affect these ones. So affected pillars. And you will call pillar behavior for each one. And now this should actually work. This should be like final. And of course, if you override the pillar behavior in the children, you don't override this one, you just override this one, then they will fire something completely different. This is why we actually overlaid this code like this, right? So that you can change how the pillars are being affected. And now if we go and duplicate these ones, let's make this one affect this one, rotate by 360, this one will be rotated for 900. We will not put self-affected, so let's just see what happens. So this one should basically rotate the self-affected. Let's try, maybe we done something wrong. Affect only self. Did we make a mistake somewhere? Let's check. Pillar behavior on overlap. This should basically work. This should basically work if I get affect only self. So pillar behavior. Let's try here. Something is happening here. Start. should be it. I don't see why it shouldn't now work. Rotate by 19. Maybe I referenced wrong one. Okay, apparently referenced wrong one in this one. So this one affects itself. Okay, let's affect self, affect only self. Let's discard that. So, okay, my bad. So this one is being affected. But now the issue is the speed in which they are affecting each other, right? So they are both lerping the same, so we need to add the speed, to this one. And speed, we need to access this one and create how to get rotate time. Get rotate. I think that this is actually that one. I forgot how does it go since I didn't work in Blueprint for longer and I need it. What was the call? It's set play rate, I think. Set play rate. It should be speed. We will make it public. And it should go basically here in this one. Okay, and now this one should rotate speed be on 0.5, let's say, and this one should be on 2. Let's look something of the same speed, I'm not sure, but never mind, that's how we do it basically. Okay, I just quickly order this to look a little bit more in line. I think that this should be basically it. So what we want actually to do now is to make some checker function. So basically the function which will help us recognize is something like is it condition true or not. So if you want to have rotation unlock, like where does it unlock? So if I figure it out correctly what you want, but it should be basically a float unlock rotation, and then we should basically pick up the current rotation adapter. So pillar unlock check, maybe pillar condition check or pillar unlock check function, which will be overridden if needed. So and then we need to take get rotation and take unlock rotation. Rotate speed as well. So unlock rotation should be single variable. We need to split this one, and we need to place equal float nearly equal, okay, to this one. then we need to basically put a return branch here, and then in return output we need set. So if it's true, if this is true and they are nearly equal, you need to do this. If not, then you are returning false. And we need to find a mechanism which will basically give us this checker. Did it happen or did it not happen? Right, so basically we need to track it somehow. So, you know, create a boolean. We want to set this one to it can be private, of course, and in event graph we need to basically call this when these functions ends, just push this a little bit up and straighten this one. So yeah, so we need to call this function basically each time when it has to see did this guy passed or not, pass the test or not, and unlocked should be basically set to this one, and this is it, and this will be basically true, you know, if we achieve the rotation which we consider to be unlock rotation for this pillar. And we can now comment it out with C pillar behavior. If I'm spelling it even correctly, that would be as well excellent. And now we need to because the pillars should have some target, and I'm not sure how you are managing the targets and how do you track are they open, but usually they have some sort of the doors like in Skyrim, right? In Skyrim you are rotating one by one once when they are all under rotation. This is why I made these different signs. When they are on the correct rotation, the doors will unlock or something. Maybe it will do something, right? Okay, so we basically need to check one more small thing before anything else. On begin play as well, it would be the best to see if this is solved or not. I mean, it has, right, and see if it's already set and you are loading from the save game or something, so it should be, you know, set on the save game. Okay, these ones are okay, more or less. Never mind. They're completely around. Okay, so this should be that one, and now we should basically implement some kind of the execution on the node which would basically need to track these ones. right? So the node which should be basically checking in the states of the things. So you need, let's on pillars affected. So on pillars affected, and you need to be binding that one. To the other object, basically. This is how it should go, I believe. So whenever everything succeeds in this one, this class actor, this one should hear about it and compare it, right? Compare all of the states in this one. So puzzle target actor. Pillar puzzle. So this one should have as well some sort of the mesh, static mesh, or maybe something else. I'm not sure, but it's not important currently. So what's important is that it has the references toward the pillars. So we need to have pillars target pillars, and it should be again reference to them. And on event begin play should be public variable of array oh my god. I think that this for each should just bind it, basically. I'm not sure, it shouldn't need anything else. You should just bind event bind on pillars effect, and then we would need basically event on pillars affect. Usually this is like naming convention, I believe you know that already, and then you need to whenever they are affected, you need to have to check if this is solved or not, right? And this is the function which you will as well be able to override. So once when this fire, whatever you defined in some function to see are they checked or not, you can, you know, have it your way. So new okay, so to see if something is of course solved, and then we will get target pillars. And for each, and this time since we have multiple and we need all of them booleans to be true, we will just set with a break, and we will break if something is, you know, false. If one of them are false, we will with the break, we will just go to the break. So these ones, and we can check if they are solved or so. Let's just see what did we name it. Unlocked, sorry. and then branch if they are on a branch. If they are unlocked, we will do nothing. So we can put, never mind, this is a stupid way, but this is not what you should be basically doing, but let's do it this time just to simplify the process. And we will puzzle solve. It can stay private. We will set puzzle solved to the true state, but if one of these elements of course fail, then we will set it to false, and then we will from this node go into the break. And then basically when it's completed, we need to execute some function again, which executes when it's on. Now what that function is, you can open the door, you can change materials or something, you can make things happen, so basically it's irrelevant. But when this is completed, we go to branch, just a second, straighten these things up, and then we are taking and putting this puzzle solved, get puzzle solved. So if one of this unlocked is false, this will fail of course, and then we need on true to execute some function which will be executed solved. And now whatever this might be, we will just print string solved. But again, you can override it in the children or in this class, or you can just put it in the children and call it, right? But we will not do this actually. We will actually not do this, because if you override this function, then yeah, so we will not do this. We will just return, we'll just make return function here, return solid, and then we will return if this is true, we will return solved, and if it's false, then we will return false. Save. So now why did we do this? Well, we did this. So checked solved, check is it solved. So first we need to check check solved, and you can override why it's solved, so it doesn't need to be this one, it can be, you can override your own, but so then we will have to do branch and check is it solved, and if it's solved, we will execute on solved. Now you can override this one, so you can keep all this logic in parent, and you can just override these functions, and it will still work. So whatever you put this one, once when you make the child blueprint, then this will be like highly modular. You don't have to change it, but if you want to change it, you can change it. And now we need basically two, since we subscribed it, we need to call. I'm not sure that we actually need to call anything else. should be done. This should be basically done now, and everything should pass. But we do need the call actually here, and maybe even on begin play. We need the call on pillar affected check, just a check. So here we need to call this one on itself, always on itself, and maybe even on the begin play, just to see the state at the begin play, to notify this guy on what's happening. I think this is it. So if we just go, because this is now on begin play, and we put rotate by to be 0 and unlock rotation to be 0, and go to play, it should notify us. Okay, salt guy. Okay, sorry. We should reference these two guys. This is for the level. I'm always forgetting this is for the level designers. So solved. So they are both solved now, because they are basically. And if this one have 90, once when we go here, it won't be solved, because not both of them are. Now if we put this one to be self-affected and rotate it for 90 degrees, and we put 180 to this one, once when we go here, it's not solved. If we go here, it's solved. They are both, and now you can place multiple, multiple pillars, do the math which one will be rotate where, and so on and so on. Maybe one more thing should be added to prevent any awkward. I think that we should basically put this to get starting rotation of this element and put it in current rotation. This should be basically the most correct way, I think, to put rotation and put current rotation to the Z rotation. But this is again just for the Z rotation. This can be even more modular, and it can be placed like entire rotation. There can be. I will try to do more on this blueprint and maybe post it somewhere, or put it on the marketplace. I'm not sure. We will see. Maybe this should go prior to this one. It would be way smarter. Okay, and now this should be entire blueprint. you can change on a interact, of course. So I will just quickly check everything. Does it works? Okay, everything works, it seems. Properly, this one doesn't. Rotate this one. Okay, and if we take this one and add the third member, let's just quickly check, and we will just increase the speed here. Rotate speed to 2, rotate speed to 2. So this one turns, it turns, now it's 90, this one turns, and it's sold. If we do this one turns, it turns a little bit more, then this one turns, it turns, nothing happens. This one turns one more, this one turns another time, third time, sold. So these two guys have both same rotation. Okay, so everything is pretty much working. There is a lot of the corrections still. Again, I will just quickly leave you guys to see and to pause here on this one. Actually on the entire blueprint. So this is the entire blueprint for it. You see, you don't have to have 1000 nodes. It can be done with fairly few nodes. This puzzle is very simple. There are fixes. For example, once when you start overlapping, you would definitely need to prevent this function from a pillar solved. You can guys check it, pause it. You can guys check this one as well. Pause it, copy it if you need, check console as well. Pause the video, look at it. This one is for you to implement, to do whatever you want with it. Let me just go quickly over concerns. If I'm about to do something crazy like this, like let me just change the rotation for 360 so that we have some time. 360 and rotation speed 1, and then when you interrupt this one, this will be a problem. So you see it's lagging and stuff. So what you want to do is basically disable it here. So you want to take box once it's affected and deactivate it here. So here you will deactivate it. And here at the end of the things, copy, when these guys are finished, all finished, you would activate it to prevent you know, weird behaviors or breaking of something or whatever. So now when you go here and enter, it will not be activated to overlap again and trigger the rotating until it's done. So this is like something preventive, and that's it guys. So once more, here is this function, here is this function. You override this one by yourself, here are these functions. So nothing complex. Okay guys, I hope that this helped you. If I find the time again, I will expand this a little bit with let's say what we can do next. It's we can create some form of let's say the variable which will be some sort of the type of unlock, and let's say we can create the blueprint enumeration unlock type, and we can call rotation, we can call it state set true or false. For example, for the switches, right, you want switches to be as well in there, so you would put all of this node into one collapse node or collapse node. Sorry. Collapse node, and you can rotate unlock type, it should be a public, you should get it, switch unlock type, and have it modular this way as well. So this one in rotation, we can call it switch, then implement the function for the switch. Once when you go inside of the puzzle pillar, right, you can decide what your logic should be, right. So we can even expand on this, but this is for some other time. So thank you, and I hope that this helps you in some way or another.